Now that we've implemented depth and capacity methods in our list stack, let's implement push and pop. So I'm going to write a test for push first. And the simplest test I can think of involving push is where I just push one element onto an empty stack. So I'm going to call this test empty push A, because I'm going to push this onto this empty stack. And I'm going to push A onto it. Okay, and the first thing I want to do is actually call the method. So I have this empty stack, and I want to push the string capital A onto this stack. And now I want to check if it was successful. So I've got some methods to do this. I'm not going to, I could test the capacity, but I mean the depth would definitely change. So I want to assert equals, and to do this I hit EA and then space, and that completes the method for me. I mean control space, and that completes the method for me. So what do I want? I want this to be 1 now. This is the expected value is 1 of the depth. And then stack depth, that's my actual value. So that should be 1. And I think we'll leave it at that. That's a nice simple test. I'll save that, and then I will rerun this test. And it fails, and it fails as you expect, because we've got an unsupported operation error that's thrown by push. So let's go ahead and modify push and try to get that to pass. Okay, so we want to push an operation onto the stack. So essentially, if we have ABC in the stack, we want to add the next element to it, like D or X or whatever you want to push onto that stack. So how do we change the representation? Well, since this list looks a lot like the stack, we probably want to push, D or X or whatever probably want to add whatever we're pushing onto the end of this list. So let's go ahead and do that. So the list is contents, and to add something to the end of a list in Java, okay, we simply do contents add, and whatever we're pushing. Well, our parameter is element, you can see up here, and that's exactly what we want to add to the list. Okay, we'll get rid of that unsupported operation exception, and we'll rerun our tests. And look at that, everything passes just like magic. Okay, fantastic. So that's a simple push test. Now I want to write something slightly more complicated. I'm basically going to, I'm going to copy this test. And I'm going to test empty, push A, and then pop. So I'm going to include pop now, but I'm still just working with one element. So this stays the same. I could leave this in here. It would be no harm to leave that in there. But now I want to pop an element from the stack. This is a stack of strings, so I have to create a string. I'll call it str, and I'll say stack and pop. Okay, so I push an element onto the stack and then I pop it. So now the stack should be empty again. So now again, after the pop operation, I expect this to be 0. And not only that, but I have another way of checking. I returned something here, so I can check what that is. I can check if that is the string A. And what am I checking here? I'm checking exactly that string, whether the actual value, which is this str, equals A. Okay, so let's go ahead and run that, and it should fail because pop is not implemented yet. So let's go back, let's implement pop. And for pop, we're returning something. Okay, so as you might expect, we want to, return the last element of the stack. Now of the list, I'm sorry, because the list is what's representing the stack. So I'm going to return contents. And the way to remove and return something from a list is to use the remove. Okay, and this wants an integer. It wants an index. So I'm not, well, I kind of know what to put in there, but for lack of for your edification, I'm going to put 0 in there and just see what happens. Okay, I happen to know that that's not ultimately correct, but let's put it in there. It wants an index. It wants some integer index. I put 0 in there. Okay, let's run the tests. And lo and behold, the tests have passed. Well, if that 0 is wrong, how in the world did we pass that test? Well, what happened was we pushed A onto the stack, and now the stack has exactly one element. All right. So what's going on is when we popped that element from the stack, in actuality, we wanted to pop the top element of the stack, which is represented by the last element in the list. By putting 0 in there, we actually removed the first element of the list, which corresponds to the bottom element of the stack. Well, why did that work? Well, it worked because the stack and the list only had one element in them. So the first element was the last element. All right. But I mean, this test stands and it passed. Okay. So we have to create a more sophisticated test if we want to really see if our push and pop methods work. So let's do a similar test. Again, we're just keeping that test there. Why not? I mean, that's a valid test. And instead of test empty push A, well, we need another. We need to put something else on the stack there. So test empty, push A, push B, pop. All right. So in that case, we're pushing A and then we're pushing B. And what do we expect here? First of all, the depth here should be 2. Okay. And then when we pop an element and we return it, we pushed A onto the stack, we pushed B onto the stack. B was the last element we pushed onto the stack, so B should be the first element out. So it was the last in, it should be the first out. That's what a stack does. So what we return here should be B. And we're going to hope, if we did things right, that this actually fails. Well, actually, it's going to fail for another reason. It's going to fail there because we should still have one element on the stack. So, yeah, so we should still have one element on the stack. So let's go ahead and run this. Okay, and it did indeed fail. And here we even got a great error message. It expected B, but it found A. So we expected B here. That was our expected value, but the actual value was A. Okay, so therefore we're going to go back and change what we're removing. Instead of the first element, we're going to remove the last element. And the last element, you can do contents, size, and you kind of have to be used to this. Just because Java starts at 0, the last element, the index of the last element is size minus 1. It's not context size. It's size minus 1. So that should be our last element. We'll go ahead and save that. We'll rerun the tests. And wonderful. Everything passes. And now that I know those basic tests pass, what I would like to do is go back to the test, and I'd like to implement a bunch of other tests. So all of these tests that I've shown you are based on an empty stack. So now that I'm fairly confident with push, I would like to uncomment this line and run some tests on stack ABC with a capacity of 6. The first thing I have to do is create that stack. So that's going to equal new list stack diamond notation 6. All right. And I'm not going to write out all these tests, but I'm just going to show you the tests I would like to do. I would like to basically test every method with that new stack. And actually, I'm sorry, let me double check something. I think I didn't do something quite right here. This stack is empty as it stands, right? I have to actually push stuff on it in my setup method. So let's go ahead and do that. So I'm going to push, I want this to be stack ABC with A at the bottom. So I'm going to copy and paste that 2 more times. Make this B, make this C. And now I've got a stack with capacity 6, or I should have, that has A, B, and C in it from bottom to top. Okay, so the tests that I would like to see are public void test, and now instead of empty, test ABC depth. Okay, I'll just put it like that. These are the tests I'd like to see. Depth, capacity, push, pop. Okay, so I'm just going to test every method here. And in fact, if you go back and look at the Java docs for these methods, this is what we used as the pre-state. Remember, ABC. So essentially, you can make sure those examples in the Java docs actually work correctly with these tests.